All right, let's begin our next lesson. Yet another strategy for solving equations, this time in the form of x to the power of n equals a. All right, so when we have a number to the power of an exponent equals another number, how do we solve for x? All right, so a couple things we need to go over before we get started is that if n is odd, okay, then quite simply x just equals the nth root of a. All right, we can use our calculator to find that. So the opposite of squaring to a number n would be taking the nth root. Okay, and we know this already. We know this. So to bring it to the other side of our equal sign, we need to do the opposite operation of rooting. All right. One thing, though, we have not discussed is that if n is even, so if n is a 2, a 4, or a 6, so if our exponent is even, then x is equal to the plus or minus nth root of a, positive or negative. And I'm going to show you why that is really quick. All right, so let's just say we have x squared equals 4. All right, we know that to find the square root, to find what x should have been, although I can just look at that and know what x needs to be, but we can take the square root of 4. And up until now, we just know this to be x equals 2. Okay? However, we know that a number squared, or a number to the power of a positive value, it could be negative or positive. So not only is 2 squared equal to 4, but also negative 2 squared is also equal to 4. So how do we know whether this is positive or negative, right? How do we know that? Well, we don't. And so that's why we say that the solution is positive or negative 2. We give both answers in that case. There isn't just one correct answer, we give both. Now, in the real world, usually only one answer applies, but mathematically, 2 answers are possible. Okay? And that's the example that I go through here as well, so you can take a look at that example. All right, so let's begin, but before we do that, make sure you know where your root bracket button is on your calculator, and it could look something like this. Sorry, that was a little sloppy, but it could look something like having an X in the top left corner and then a Y underneath a root bracket. Okay, that's the button you're looking for to solve a lot of these questions. Now, get familiar with your calculator so you know what to press first and what to press second and third and so on. So what I mean by that is, like, take an example that you know the answer to, like the cubed root of 8. We know that that's 2, right? And now try to plug in cubed root of 8 into your calculator. Okay, because different calculators have different orders in which you press the buttons. So make sure you get the answer 2 when you try to take the cubed root of 8. All right, so let's do the fourth root of 81. Once you've done that, all right, I can tell you that it's 3. But because we took the fourth root, do you leave the answer as just positive 3? No. We don't know if the answer was 3 times 3 times 3 times 3 equals 81, or negative 3 times negative 3 times negative 3 times negative 3 equals 81. Both are true mathematically. Okay? The cubed root of 125. Okay, so the cubed root of 125 is 25. Okay, again, just use your calculator. All right, so it says determine the real roots, round to 2 decimal places. Okay, that's what we're going to do here. We're going to be rounding to 2 decimal places, so make sure that we do that. Okay, so starting with x to the 4 equals 72. Well, we're going to take the fourth root of 72. Okay, and what you're going to get, again, because you're taking the fourth root, it's going to be plus or minus 2.91. Okay, round to 2 decimal places. Next is the cubed root of 50. Okay, cubed root of 50. This time we don't need to put a plus or minus. It does not apply here. you get 3.68. Okay, so very easy and straightforward so far. There's two more slightly more complicated examples that I want to do with you before I assign some practice questions for this. And one of them being, what if you have terms inside of a bracket cubed? Okay, well, the first thing you need to do is move this cubed over to the other side before you can do anything with this -5. All right, so it's following reverse BEDMAS rules to isolate for a variable. So you end up getting x minus 5. We can now drop the brackets because we are removing the cubed and turning it into the cubed root of 64 on the other side. The cubed root of 64 is 4. Okay, now we can move the -5 over, becomes 4 plus 5, and x equals 9. Okay, so very straightforward there. Just make sure that you move the cubed operation to the other side first before you touch what's in the bracket. All right, here's another situation where we have a -2 as an exponent. All right, so this is somewhat new to us. You cannot take the negative root of a number. Okay, so you can't take the negative square root of a number. All right, so we're gonna have to figure out a strategy to be able to solve for this, and we have the tools necessary to do this. We've learned something about exponents, something that we can do when we have negative exponents that turn them into positive exponents. Okay, so if you guess that you can take 3x to the -2 and change it to 3 divided by x squared, which is equivalent, okay, write out the rest. All right, and now let's begin to solve for x. So let's move the -4 over. Becomes 12 plus 4, which is 16. So you end up with something like this, okay? Now, we're not, you might feel slightly uncomfortable with this, but remember, when you have a ratio equal to another ratio, which is really 16 over 1, you can employ cross-multiplying, okay, to move or to begin to isolate for x. So you end up getting 3 equals 16 times x squared. Now this is an equation we know how to solve. We're going to divide both sides by 16. Okay, divide both sides by 16. Okay, and then the last step is take your square root of 16. Okay, square root of 3 over 16. Okay, so take the square root of 3 divided by 16 there, and you end up with, okay, 0.43 to 2 decimal places. Now, don't forget, because you're taking square root, put your plus minus there, okay? Plus or minus. We know that it can be the positive or negative value there that ends up getting that solution. All right, so there you have it. This was a quick lesson today, just going over some new strategies just so that we can handle more different situations when it comes to solving equations.